All right, in this video we're discussing basic probability, and you'll see two formulas on our screen here. We have the first one that says probability of A is equal to the number of times A was observed divided by the number of observations made. And that's the formula we would use if we had a sample of data and we were trying to estimate an unknown probability. We would go out and collect a sample. For example, if we wanted to know what percent of the population actually had green eyes, we'd go out there and collect a sample of people. We'd count how many times we saw people with green eyes in our sample, divided by the total number of people in our sample, and that would give us an estimation of what the true percent or proportion of green eyes in the population is. Okay, now the second formula here is sometimes referred to as classical probability, and this is sort of the probability that can be done in your head as a thought experiment. For example, rolling a die. If we roll a single six-sided die and I want to know the probability that it turns up to be 3 on the die, I would just say, well, how many 3s are on the die? In other words, how many ways can 3 occur? Well, of course, there's only one 3, so in that case, the answer would be 1 divided by the number of total possible outcomes. Well, since the die has 6 sides, it would be 1/6, and that'd be the probability in that case. The assumption here is that each of those outcomes on the die are equally likely. So when you're dealing with sort of classical probability, the underlying assumption is that each of the outcomes occurs with equal probability. And that way all you have to do is count up the number of outcomes that meet what you're looking for and divide it by the total number of possible outcomes. Okay, so let's look at a very basic example here. The problem reads, my most recent STA 3123 course had 191 psychology majors out of the 239 students enrolled. What is the probability that a randomly selected student from that class is not a psychology major? So first thing, it says clearly that we're looking for probability, right? So we know it's a probability problem. And then it's important here to pay attention to the fact that we're only selecting one student, right? That's really important because if it was more than one student, the type of probability needed to solve the problem would change, it'd be different. But since we're only selecting one student, if there's one selection being made, we usually can use one fraction of probability to solve the problem. So we just need a single fraction of probability. And then, of course, we have to know what we're looking for. We're looking for the probability that the student is not a psychology major. So let's write out a statement because that's where all the thinking occurs. It's all in the writing, right? So we're going to say the probability that we get a non-psychology major student. So we'll say a student who is not a psychology major. I'll abbreviate that. But that's essentially what we're looking for. Now you could write this a little more efficiently. You might say something like, I'm going to write this as the probability of psych major as P, right? P for psych major, and then I'll put a bar on top, and that means not a psych major. So we could do that as well, right? So that's a common shorthand notation. But remember that these things are really the same. Now, what we want to do whenever solving a basic probability problem is to write this as our numerator and denominator of our fraction. We're going to say number of over total. Number of over total. Now the reason why I want you to do that is because then you're going to think about what goes here. In other words, what are we looking for? The number of what? In this case, we would say people who are not psychology majors, right? Or number of students who are not psych majors, right? I'll just abbreviate that again because we don't want to run out of space. And then we'll divide by the total number of what? Total number of, and to get this answer, what goes here, it's the total number of things you were selecting from. So what things were you asked, what were you taking, right? What was the selection being taken, right? So in other words, it says, find the probability that a randomly selected student. So we're taking students, so this is the total number of students. Does that make sense? I hope so. So the idea is the total at the bottom is related to what you're selecting. If you're selecting students, then it'll be the total number of students. If you're selecting cards, it's the total number of cards. So you might have a question that says, find the probability when you select a card from a deck of cards, the card is red. Well, okay, so the number of over total would be number of red cards over total number of cards. Again, total number of cards because a card is what you're selecting, right? So this is our fraction, and now that we have it all written out, there's nothing really much to do here except for to determine the numbers that go in the positions, but that's going to be fundamentally more simple than the thinking we just did up to this point. So the reality is that all the hard work is done up front when you're doing the thinking that writes out these phrases. All right, so we're going to have probability of not a psychology major, and that'll be equal to, well, how do we get the number of students who are not psychology majors? We know that 191 students are psychology majors, and there are 239 total students. So to get the ones that aren't psychology majors, it should be just a difference, right? 239 minus 191. That will give us the number that are actually not psychology majors. Okay, and then we're going to have to come up with a total number of students. Well, again, the total number of students is 239, it says, so 239. All right, so let's just work that out in our calculator to get our final solution. So on top, we'll have 239 minus 191. Close that up and divide by 239. And your final answer, rounded off to 3 decimal places, is 0.201, or 20.1%. So it'll be 0.201, or you can write that as 20.1%. So there's a 20.1% chance that a randomly chosen student from this class is not majoring in psychology.